Okay, welcome everybody on this webinar about improved traceability of parts and products. I believe there will still be some people logging in, but it's better to start right now.
Nee, wat er is dat ik start een webinar op, maar praat maar rustig door.
Sorry, can you put yourself on mute? Thank you very much. It's all about improved traceability of parts and products. Shortly before the concept phase of this project, which was about in 2017, 2018, the Gartner Hype Cycle only characterized the application of blockchain in supply chain as an innovation project, with the prospect that it would, let's say, be more effective in about 10 years. The researchers on this project have proven that maybe 10 years is a little bit too far out, but at least that it can work. And it is no coincidence that this project was done with two companies, Fokker Services and IBM, because these companies are known for their, let's say, innovative approach in their businesses and with their customers. It's all about traceability of high-tech products, and it is proven to be possible now that it allows you more advanced transactions, such as maintenance, relationship with payments, and solving problems and disputes, which is very good to learn. Why is this organized with the Service Logistics Forum, with SLF? That is because the SLF was a partner of this project, and particularly a partner for the dissemination of knowledge in this whole project. For those of you who are not familiar with the SLF, we are a network organization as a non-profit foundation, and we're all concentrating on, let's say, service logistics or service chain management, and it's about knowledge, know-how, and the stimulation of innovation and talents in this business. Of course, please feel free to join us in this network, and we organize sessions like this, but also physical sessions. This year, SLF focuses on a lot of technology enabling the service chains. Some practical points are on the slide to come. Remco, can you? Yes, please, thank you. It is already mentioned that it is recorded. Please, if you don't speak or asking a question, turn your camera and mic off. If I see in the chat that there are questions, then I will either ask you to ask that question, or I will ask the question to the speaker. I think it's nice to ask questions throughout the presentation of the particular speaker and not to wait till the end of the webinar. We organized it also with the European Supply Chain Forum, and the project was sponsored by the Top Sector Logistics and the TKI Dialogue. I think for now it's about time that Remco takes over and talk about the project and the other speakers. Thank you very much.
Yes, thank you very much, Ben. And before we start indeed with the content part of this presentation, let me take a few minutes to set the scene. Indeed, the webinar is on improved traceability of parts and products. And so I know that many of you are supply chain managers or something like that. So many of you will be familiar with what is going on here, but there are also people who are not. So let me just set the scene a little bit. Imagine that you maintain airplane engines. So that's not an entirely fictitious scenario in this context, as you will soon learn. But suppose that you maintain airplane engines. Of course, you need parts to maintain those airplane engines, and you will want to procure those parts from some producer who produces the parts, and then via maybe some intermediate steps, make sure that those parts get to you. And then, of course, there will be there's much information that you need about these parts. Most specifically, the airplane industry is a very regulated industry, right? You want these planes to stay in the air, so you will want the quality to be carefully monitored. And for that reason, the parts and the information that you need to have about these parts is also strongly regulated. And you want to make sure that you have this information, that you have the certificates that you need to assure the quality of your parts. So you need a lot of information to do your work, to trace what parts you have in your product. And you need that for maybe certification purposes, but you may also need it for different purposes. For example, at a certain stage, you may need to do a recall action. So that recently happened a couple of times in the car manufacturing industry. So you want to know which clients bought a product that contained a particular part or a particular version of the software, so you can update the software. So for that reason, you want to make sure that you know at all stages what products you have, what parts are in those products, which clients currently own those products, and maybe a lot of other information as well. Now, that's of course not just relevant in the airplane, in the aerospace industry, but there are many industries in which this applies as well, that are more or less regulated. So that is a bit the context of this project, right? Being able to know at all times what is going on with your products, what is going on with your parts, and who owns it at this particular point in time, so you can take appropriate action when you need to. So with that in mind, we started the IToPP project, the Improved Traceability of Parts and Products project that Ben already mentioned, because what we saw and what we thought is that blockchain may be a very suitable technology for doing this. So what we did is we took a generic blockchain platform, and we started making that specific for traceability purposes. Very specifically, we applied it in the aerospace industry. So we work together with our partners from Fokker, and we will soon learn from Wouter van Dis from Fokker what exactly the challenges were that they face on a daily basis, and how he feels that traceability, and in particular traceability with blockchain, can help them. But we also looked at a couple more partners, and we have IBM on board also as a project partner, and they of course do this for real on a daily basis, and they have a more general perspective on using blockchain in supply chain. So with that in mind, with that structure in mind, we set the agenda for today. So what first, Wouter van Dis will explain what parts and product. So if you're not speaking, could you please turn off your microphone? So first, Wouter van Dis from Fokker will present the challenges that they face on a daily basis regarding traceability. Then I will present again, and I will explain how we feel that blockchain can help with that, and we will also demonstrate very briefly the prototype that we have created for Fokker. And then IBM will take it broader, and they will show how in general blockchain can help in supply chain management. But without further ado, let's dive immediately into the content, and I will ask Wouter now to present the challenges that Fokker faces in traceability.
Yes, thanks. Thanks, Remco. Let's see if I can share my screen. That's it. That's it, I guess. So thanks, Remco, and thanks, Ben, for the introduction of this webinar. Let me introduce myself first. I'm Wouter van Dis. I have 29 years experience in the aerospace maintenance domain. And currently I'm holding a position as Advanced Analytics Manager within Focus Services. Focus Services, for the people that don't know, is an independent aerospace service provider. We supply parts, offer component availability, programs and maintenance services for more than only Fokker airplanes. We do this for various different aircraft types. I am running a department with data scientists, data engineers and BI specialists, and we're connecting data from various sources, not only our ERP data, but also market data. And we're enabling predictive analytics and operational decision support within Focus Services. If you are interested in contacting me, I have profile on a LinkedIn ID, so you can easily find me, I guess. So the importance of traceability in the aerospace supply chain. So if I'm going back to my role as Advanced Analytics Manager, I'm definitely interested in the historical data of aircraft parts. And what do I mean with that? Well, I'm interested in when they were manufactured, for instance, and how many flight hours did a component made before it failed on the aircraft. In which kind of continent or environment was it operated before it failed? And how many times did the plane landed and in which conditions? It's that kind of stuff that I'm interested in, but also in the previous owners and operators of a part. So in that context, I'm interested in to have a better visibility on what the life cycle of an aircraft component of part is. In the next few slides, I will explain the traceability of the aircraft components in the aerospace supply chain. So what's traceability? And the easiest way is, of course, for me at least, let's go to Wikipedia, seeing what Wikipedia is saying about it. The ability to verify the historic location, application of an item, and the mean of documented, recorded identification. So the document recorded identification, in particular, like the first part that was way too difficult for me. So the process for locating components and their appropriate history through their life, I like that a little bit better. So if you look at the aerospace, all parts of an aircraft are fully traceable to the raw material it's made from. And it even includes not only the material it made from, but also the process steps that the manufacturing or maintaining the part is traceable. We know which technician maintained the part 10 years ago. That's the traceability part. This traceability is key to the safety. That's what it is. That's why we safely fly and why we the air travel is one of the safest way to travel. But if, and we all understand that if there's something going wrong in that tube that we fly on 30,000 feet, then the implications of when something is really going wrong are pretty catastrophic. So, and if that's happened, you want to know what happened. And that's where the traceability is coming back into place. I think it's a no-brainer. It's clear. That's why we do this. Let's explain a little bit, and I've super simplified this, of course, what aircraft maintenance is about. So let's take an example that an aircraft needs maintenance at a point. So to perform the maintenance, parts are needed. And that can be washers or bolts and nuts and brackets, but also more expensive components like computers or actuators. And those parts need to be manufactured, and you need raw material for that to manufacturing that. Some parts in an aircraft are what we call rotable parts, repairable parts, and they are removed from an aircraft and replaced by a good one, a kind of exchange program thing. And that part is going to be sent to a component maintenance shop. And that component maintenance shop needs, of course, also parts that are newly manufactured to be able to repair that component. And if you look at this whole thing, then all the arrows that you see are traceability traces. We know where this is coming from, and we know eventually the raw material in our industry. And all the companies that are involved in this are certified by the authorities, and they are audited on a regular basis on their processes, which is also important in this. So we talk about the process that is highly regulated, actually works, is safe. So what's to gain? So let's see where my interest is. So if you look at the domain, and we sketch this a little bit with on the right side of the screen. There are various organization types in that domain, like operators, maintenance organizations, parts brokers, manufacturers, just to name a few. And we're doing business with each other. And on each transaction, data interchange is necessary to ensure this traceability that I'm talking about. So while companies internally rely on their ERP systems and quality systems to ensure the trace of the materials and the processes that they did, business to business and company to company, we rely pretty much on a paper trail to document that trace. So as an example of those paper documents that we need to be able to make sure that if we accept a component that it is according what we think it is, we want documentation that's providing that this is manufactured according to specification, and certificate of conformity. That's what we call it, and I think that is an industry-wide name. But yeah, again, 29 years in the industry, might be that I'm wrong. But we also want the last maintenance that's performed and the current condition of the part, and we probably want to have something identification that the part was not involved in an incident which might affect that part. Previous operators, flight hours, like mileage reports as we do in a car. That's the kind of stuff that we want to have before we starting then a transaction. It is very important to understand that if you look at it, that the trace file is not a complete, what I call a medical file. It often goes only to the previous operator and the previous maintenance performed, but it is not the complete history of that component. There is a disclaimer here, because you think, well, that's strange. Yeah, an aircraft and an engine, those are regulated, and they have, when you sell an aircraft or when you buy an engine, you know the complete history of that aircraft. But if you look at it solely the components, a computer, you can trace it. But you not having with the push of a button the whole history file, the whole medical file of that component. And actually only if you're looking at new components, we transfer the birth certificate with the new component. And if we talk about bolts and nuts, where they probably made in thousands, and you only want to buy 10, you have copies of that originally certificate of conformity. So if you look at this, you're saying, hey, we have a traceability is completely compliant, there's no problem. That if you are a company downstream the supply chain, you do not have an overview on the complete history of the part. And if you're a company upstream the supply chain, you don't know what the current status of that part is that you probably manufactured, or which is the owner at this moment, or what the location of that part is. So that's the current system. So if you now to give a little bit of an hands-on on what that means, if we, for instance, doing a transaction and buying a second-hand aircraft component like a computer or an actuator in the aerospace domain, and we probably ask for a document of 5, something like that. And what we want to know is if you buy that, and I'm a buyer of focus service and say, hey, I like to buy that part because I need that. You want to validate if the component is as advertised. Yeah, is it really that component? And we need documentation for that. So the ATA 106 is into place. And if you can use it on an aircraft, and for instance, it's not involved in an incident, so we have a non-incident statement for that. And you want to have the current status. So is it serviceable? Is it overhauled? When was the last time it had maintenance? The FEA EASA Form 1, which you see at the second document from the left, is a well-known document for us to trace that. And that has also something, all these documents has something to do with I'm going to pay a certain amount of money. Is it worth that amount of money? We have a lot of people that are knowledgeable to be able to assess that. And most of the time, a bunch of these documents are already shared before the transaction is made. So you're saying, I want to buy that. Can you provide me documentation which is going to be attached? What I'm always saying, 50% is the part and 50% is all the trace paperwork behind it. And if one of the two is missing, it's not worth anything for me anymore. And then if we receive it, if we do the transaction, then for the quality and for our business processes, we want these hard copy documents as well. And most of the time we scan that and we archive that, and then and that's what's also the process that we are getting audited by the authorities. Yeah, so there's a lot of paperwork and there's a lot of hands-off and hands-on. So what's to gain? And I think what's to gain is a more sustainable and much more efficient ecosystem. And I think that I found this, you can better steal it off the internet and then think about it yourself. So that's not my work, but it makes a pretty good impression. This is what you want. You want a digital platform, a common rail, that you have your whole life cycle of your part in, more or less. And then you can imagine that that we reduce a lot of burden in paperwork trails, and that you increase efficiency and quality and the operational execution of this whole trace, and that the whole supply chain is able to be able to better forecast and less overproduce, and that we get better control on counterfeit parts. And I think that if you going even further, that you can even find 4 more of those arguments. So this is the interesting part, and this is one of the things that I think we can prove that the ability is there, and that blockchain might be a solution to provide this. So what's the future? What's the vision? The future will be a place where every part has a trusted digital identity, historical record that's immediately accessible to those with the right credentials. I think that we at least try to build that prototype that's doing this. So I hope that I gave you a little bit of insights on the traceability in the aerospace at this point. And if there are any questions, then it's now time to ask those. Let's see.
Hi, Wouter, Ben here. There is a question from Jan Faber. But Jan, can you ask the question yourself by putting on your screen and unmute?
That's no problem. That's no problem. I was not sure how much Wouter was going to share after. Thank you, Wouter, for the insight. I was wondering whether all the paperwork is shared with every participant in every transaction, or whether there is already some of maybe digital library or repository.
You're breaking up a bit, but I think that you're asking the question that if it's really all paperwork at this point, and if there are already parts digital. So there are specifications to make digital things happening between companies if they agree upon. But if you look at Focus Services right now, the traces are paperwork, and paperwork is for me also PDFs, by the way. So I'm a little bit if you find that digital, then I will shake a hand and say, okay, then we have a digital transfer. We do a lot of PDFs back and forth, and I'm not considering that a digital connection. That's just a scanned piece of paperwork. But I think that the answer is no. We do this pretty much on paperwork.
Okay, is that clear? So the project will have paperless, let's say, more reliable environment here. There is another question from Koos van der Meij. I will ask the question here. It's a great explanation in your presentation. How did you accredite the data value input?
How did you? It's probably my connection that's breaking up.
Accreditate the data value input.
Let's see. Let's understand this.
Koos, can you come in and give us a brief explanation about your question?
Yes, I can. Well, thank you. It's a great presentation. I was wondering, to have blockchain in the optimum, you need a validation of your data input. And how do you guarantee that validation, accreditation on the data input?
Yeah, okay. Let me think about if we really did this in this project. So the blockchain principle will be explained, I think, by Remco. And Jari knows all this from IBM, knows this also very good. The idea is that there are organizations who are able to manufacturing parts, and that these will have credentials in that blockchain, and let me say this correctly, of adding this into the blockchain. So they are, as an organization, they have certain rights to be able to add this into the blockchain. And then we can transfer, and you need to confirm as a company if you transfer a certain part as ownership. I think that you're asking a question that we need to think about if we.
Oops.
I think Wouter is frozen now.
I think yes. I think Wouter is offline somehow. Shall we go on with the next presentation? Sorry for the interruption of this question and answer, but I think it's best now to continue with the next speaker, and that's Remco.
Thank you, Ben. I'm in the process of sharing my screen. And it should be shared now. So thank you, Ben. And so let's go back to this slide. So this was the slide I already showed during the introduction. So this is what it's all about. You have a supply chain, you have people upstream and downstream in your supply chain, and what you want is at all stages to know what is going on with the parts and products that are relevant for you in the supply chain to answer the questions that you see above. Now let's assume that Wouter convinced you that you need some kind of data platform to be able to share that information with each other. Then of course the question remains, why would blockchain be the suitable data platform or the suitable technology for this data platform? And that is the question I would like to answer in this presentation. So what I would like to do is I would like to start with the desired functionality that you would need for such a traceability platform. Then I will show you, so I will also explain why we think that blockchain provides that functionality. I will then also show the prototype tool that we developed, so we can hopefully convince you live that blockchain does indeed provide the necessary functionality. And of course, there's also always a financial aspect to this, right? So probably you will have to pay some money to have blockchain implemented in your company or to buy a service that Fokker may be providing at a certain stage. But what's in it for you? Can you somehow get those costs back? So what is the desired functionality of any data platform for sharing part and product data for traceability? Well, obviously, the first thing that you need to do is you need to share data. That is no different from any other platform, and I will not go into much more detail there, but I will show you later how blockchain stores that kind of data, because there's a certain principle to it. Then, in addition to that, there are rules that apply to that data that you need to enforce, right? So especially in regulated industries like the one of Fokker, we have this rule that your product must be certified and must be certified by a manufacturer that is itself certified. Now, to maybe get a little bit ahead of my story, but to hopefully answer the question that Koos asked, right? So the question was, how can we be sure that these manufacturers or other partners in the supply chain, that they provide the correct input? Well, that is why they are certified. They are assumed to provide the correct input, and you need to have some form of governance in your blockchain service to make sure that you only allow certified manufacturers onto the blockchain to add information, and then by construction you assume that these people will provide correct information to you. So that's a governance aspect. But right, there may be many different rules that you can that you may want to enforce, right? So there was the mileage problem at a certain stage. You want to know how many miles an aircraft has flown, how many hours you have used a particular part, and can it still be reused at a certain stage. There are, of course, many contractual obligations that you may need to enforce. And this is really the reason why you are storing that data, because you're not just storing the data so that you can take a look at it, but you're storing the data so that in the end you want to have some integral picture of it, and when a certain question arises or when you want to check if a certain rule is properly enforced, you want to be able to do that. Also, somehow you will want to organize trust. You will probably work directly with some people one stage up and one stage down in the supply chain of you, and you will probably trust those people, at least to some degree. But where it often goes wrong is when you start to look more than one step ahead or backwards of you in the supply chain. So what you need is you need to have some way, so it may be that your client trusts their client, but that doesn't necessarily mean that you trust their client, or that your supplier trusts their supplier, but you do not necessarily trust their supplier. So you need to have some form, some organization of trust to make sure that, right, everybody in the supply chain is trusted to enter the correct data and to always report what needs to be reported and things like that. So the usual solution that is used for that is to have some trusted third party, or TTP, and you will trust, or you agree with multiple people in the supply chain that you trust this trusted third party, and that trusted third party will make sure that certain partners in the supply chain are trusted themselves. And in that way, transitively, you can arrange the trust in the entire supply chain by, like I said, governance rules only allow people in the into the supply chain or into the platform that can be guaranteed to enter correct data. And then we need some kind of mechanism, some kind of technology for exchanging the data that we are talking about. And of course, one very simple technological solution is that you entrust one party to collect all the data, to store all the data, and to properly maintain all that data. Now, if that makes you feel uneasy, have one party trust one party, not necessarily you, but trust one party with all your traceability data. If that makes you feel uneasy, then you're not alone. Many people are uneasy, many companies are uneasy with sharing their data at all, and that is why this is typically not happening. Every partner keeps their own traceability data, and at best there are some interfaces between these personal or these company-specific platforms to share traceability data when it is necessary. Of course, what would be ideal is if there would be no one controlling the data, but the data would be available to everyone according to some rules, some pre-agreed upon rules, and these rules would also, of course, say who has access to what data specifically. So maybe somebody should only have access to data if you explicitly gave them access to that data, but when they do, they also have access to the complete history trace. So for example, suppose that you are negotiating with a potential buyer, you may want to give them access insight into the information on the part. Do you have indeed the certificates that are needed for that part? So you will want to give them insight, and but at the moment they decide not to buy, you will want to revoke that insight again, that access to the data. But these rules, they would have to, they would be flexible, but there would be some way to automatically enforce them. But no one owns the data, so at the moment one of the parties drops out, or this central party that we had on the previous slide drops out, at the moment somebody drops out of the blockchain, the data would still be accessible according to the existing rules to everybody who has access according to the rules. And everybody will at all times also be able to, according to the pre-agreed rules, give people access who need access and deny people access who do not have access. So those we feel are four of the essential pieces of functionality that you would need from such a platform for sharing traceability data. So obviously you need to be able to share data. You will want to enforce the rules or be able to answer the questions that you have regarding that data. That is the whole goal with which you store that data, with which you exchange that data. Somehow you need to be able to trust everybody who will be on this platform to enter the correct data and to treat that data properly. And you will need some technology to then, of course, exchange the data. Now, as a true salesperson, I put then check marks saying that blockchain provides all this. But as a true scientist, I immediately want to weaken that claim. Yes, blockchain helps you provide all this functionality, but obviously you will need to do some work yourself. Let me go quickly through that. So it's not like blockchain is the silver bullet, and once you implement blockchain in your company, you download a Hyperledger and you install it, immediately everything works. Unfortunately, that is not the case. So that is my failed sales pitch for you. But blockchain does very much help you to get this functionality. So first, for the data, it is important, but we actually feel that that is a very good medium. Blockchain stores data in a transaction-based manner. That means that every time a significant event happens, you can store it on the blockchain. And what you need to do is you need to, and these are called transactions, based on, of course, what kind of the origin of blockchain was, the Bitcoin. But be very careful. The type of blockchain that we're talking about is very different from the blockchain that is being used to manage things like Bitcoin. So it's transaction, let's call it event-based. Every time something significant happens in your part or product that you want to store, that generates an event, that generates a transaction that you will want to store in the blockchain. So for example, when a part is produced, you will want to store that that part is produced with some additional data, like the date on which it is produced, the batch number that it was a part of, and in the case you are dealing with a regulated industry, the certificate that says that this part is produced according to the required quality rules and regulations. So everything is an event, everything is a transaction, and what you need to do is you need to identify the transactions, the events that are relevant in your particular industry, and what data you want to keep for those events. Of course, the most recognizable events or transactions are transactions that are about transferring the ownership from one party in the supply chain to the other party, which are, well, also in the conceptual sense, transactions, which you of course also want to store, and so on and so forth. So everything that is relevant for a part generates an event in a trace that stores everything that has happened with the product that you feel, or the part that you feel is of interest. Then there are the rules that you will want to apply to the blockchain, and I will show you a very simple rule at a later stage. Like for example, if you produce a part and you store it on the blockchain, you need to add the certificate to it. If you don't, that is not according to the rules. Or if you buy a particular part, you need to pay within 4 weeks or something. And so those are rules that you want to enforce throughout the blockchain. And actually the blockchain provides some very good technology for that, which I learned to value very much while we were doing this project. and those are smart contracts. So smart contracts, basically every time a transaction happens, the smart contracts are checked to see if all the rules that are put in the smart contracts are still okay, are still being observed, and if not, this will be signaled. Then there is the trust. Again, blockchain provides some principle for arranging trust. Like I said, we are not talking about open blockchains like Bitcoin, where everybody can just create a wallet and join the blockchain. These are closed blockchains. You will allow only people on the blockchain who you feel have a good contribution or who meet the requirements for being allowed onto the blockchain. Obviously, the technology that you're using then is blockchain. And as I said, the main benefit, I think, of the blockchain is that there is no single party owning the data that you are then dependent on, that you have to pay money to, but everyone who is on the blockchain co-owns the blockchain, co-owns the data, but every single partner in the blockchain can decide on the rules if they feel that the rules are work for them. And these rules will be automatically enforced. So through these smart contracts. Of course, right. This is another platform. So one of the things that you still do need to do. You probably don't want to have your ERP system that you are using for storing your own parts and products data. So somehow you will still probably want to make sure that the information from your ERP system gets onto the blockchain and vice versa. So actually for the prototype, there's also a link to the prototype, which I will be presenting next. We have built an interface with Fokker's ERP system, and they're currently, as a test case, I think they are pushing 6,000 products per week to the blockchain, 6,000 transactions via their ERP system. So indeed, this is the functionality which blockchain can provide. So I hope that that interests you. And let me then show you how we have used this for the Fokker case. So as I said, you identify the data. You need to determine what are these transactions, what are these events that you feel are essential to register. And so we identified 6 essential events: the production of a part, and very much, of course, when we're talking about nuts and bolts, these are produced in huge batches. So then you may want to split off those batches into a part that goes to one customer and a segment that goes to another customer. And there are a couple of these transactions that we have identified with the data that we feel needs to be assigned to those transactions that need to be stored for each of these transactions. We have identified contractual rules that need to be observed, and we have enabled physical traceability. I will show you in a second what that means. One thing that we felt is very important. So even though, right, we only allow, so we have governance rules, we only allow people on the blockchain, certified manufacturers, certified MROs, so people who we trust to enter correct data, but still then, even with a certified partner, you can enter into a dispute about the data on the blockchain. So somebody says, well, I delivered 1,000 nuts to you, and you say, but I only received 900. At that point, you can open a dispute, and you have to then find a way to resolve that dispute. All that information is stored in the blockchain, because the nature of the blockchain is that no information can ever be changed with hindsight. So you can edit, you can make changes, but the original information will also still be there, saying, well, originally it was said that 1,000 pieces were delivered, but it was only 900, or yes, indeed, it was 1,000. So that information will also be part, and the fact that there was a dispute about this will also be a part. Of course, if you don't want that to be visible later on, you can put in the smart contracts that only the latest information will be available, or something like that. And we built, as I said, an ERP interface. So this is what that looks like. And you can actually go right now to IToPP with WP.nl to check that out for yourself. And what you see here is you see the list of parts that somehow you want to be able to trace. So these are examples that we entered at a certain stage from Fokker. So this is still an earlier version where we only entered some example data. And then when you would click on one of those parts, you would get this trace that I have been talking about. And this trace, it provides you all the information on the transactions, the events that happened on these parts, and it will allow you to then do additional things like, as I explained earlier on, like splitting an order. So this of this particular bolt, there are currently 50 in this batch, and you can split off this batch into 20 that go to one customer and 20 that go into one particular airplane engine and 30 that go into another airplane engine. You can also see, and that is what this red button over here means, that rules are being enforced. So apparently here we are dealing with a part for which there is no certificate. And then the person who programmed this blockchain, who was Utkan Eryilmaz, he made this visual representation, so shown in red, that this particular rule is not observed. Then regarding the physical traceability, we have created, so that was actually for the people from Fokker were very happy with it. We were also very happy with it because for us this was a very minor thing to build. We created for every part, well, that's being created when the part is produced. A QR tag is produced, and of course the physical traceability. The idea is that you put this QR tag in some way. You put it on the part or on the back of nuts that you are using. You can actually scan this QR code and you can see that this indeed works. By the way, if you scan this QR code, this is not the QR code for this particular part. So you will see another part. Yeah. So there's a technical reason behind it that I won't bother you with. So those are some of the main functions of this blockchain prototype. So is this all worth it? Should you invest in blockchain technology for parts and product traceability? So we feel that there are two potential benefits to the blockchain. One is that you now have shared information, and that that means that when you buy a part, you don't need to collect that information anymore, as was the main problem that Fokker had, that they spend a lot of time collecting the information on the parts to see if the part is worth it, to see if they're even allowed to use it, because they need to have these certificates. Well, I'll get to the second point in a bit. So this shared information, it saves time. You don't need to, if you have the information, you don't need to collect it yourself. And we estimate that for that reason, buyers are willing to pay more to have that information. At least they will want to be able to, they will want to pay the amount of time it would normally take them to collect the information. We also estimate that it may be the case, we actually use different variations, that buyers are willing to pay more for more reliable information, where we say that, well, if it's on the blockchain, it's more reliable because at all stages it is being confirmed and it's being certified by everybody that this is the correct information. So we did various studies or various analysis to see if that would indeed work using a game theoretic simulation model. And I feel that this is the, well, if you're interested in more of the details, I would be happy to share the paper with you. But I just want to share this particular graph with you because I feel this is the most accurate representation of what is going on. So what we found is actually, when you use the blockchain, this is the level of blockchain penetration. So how many companies are, what percentage or what fraction of companies is using the blockchain at this point. And of course, when you're the only one on the blockchain, actually it's only costing you money. So you earn some money by selling your parts, but you have to pay a lot for the blockchain that you are the only one operating, and you're not benefiting from it because nobody is sharing information with you. So it's only costing you money. Then other people start using the blockchain too, and you can see that it starts to pay off. People start seeing the benefit of this shared information, and they're actually more eager to buy from you than they are from your competitors over here that are not on the blockchain. So I feel that this is the most reliable information. And then we found that, well, you don't need that large a blockchain penetration, so only 10 or well, around 10 or 20% market penetration before this starts to pay off. Yeah.
A specific question from
Ben, I think you're very far from your microphone. Maybe I think your microphone is in your laptop. Can you speak closer to your laptop?
You can hear me now?
Yes.
Okay. The question is what blockchain, and this example is the cost saving in auditing and reporting efforts. That's the question.
Is the blockchain model, is the business model for blockchain, for this example, the cost saving? Yes, indeed. That is basically the case. So, yeah, so in at Fokker, they have to do the auditing while they are buying the, but Wouter knows more about this than I do. But in Fokker, they have to do the auditing basically while they are doing the part. While they are buying the part. If they buy a part that is not certified, it is useless for them. They cannot use it in their airplane engines, so they wouldn't buy it in the first place. So they do the auditing while, but you can also, of course, do it after you have bought it. That doesn't, yeah, that's just a timing aspect. That doesn't really make a difference, I think.
Okay. And another question maybe on this particular point right now from Annemaas Blinken.
Yeah, could this also be applicable to bulk products, oil, or rather to discrete data items and parts? Yes, I think I see no reason why it wouldn't be applicable to bulk products. So the main difference, I think, with bulk products is the way this split operation would work. So I don't immediately see how that. So I imagine that at a certain stage you agree to ship a certain amount of oil to a customer, and then that customer splits it off. So let's say you are selling 1,000 liters of oil, and then that customer splits it off into 500 liters that go to another customer and 500 liters that go to another customer. So I would imagine that we can very easily change the split operation to also work for bulk products. So I don't see why it wouldn't work.
Okay, thank you. Sorry to interrupt.
No worries.
May I ask some question, Remco, Ben, now?
Yeah.
Yeah. So I've added also in the chat, but it's also related to my first question to Wouter, and you already mentioned, Remco, that it's a part of governance. Well, first, let's say you have a good visualization and presentation of the whole part. So, and I have a critical question, but I don't say that it's not. I think it will help you to make it more stronger in the end. I think I'm missing in the list of data really the validation, because in my opinion, the added value of blockchain technology will be that it cannot be replaced to, for example, an ERP system. And if you let out the validation, a decentralized validation part, then we are all talking about the same data and the same validation. And in my opinion, it's needed to have it also, because I love smart contracting, and because the technical possibilities of decentralized ledger technology is really great. But if I put manually the wrong information, how is blockchain helping me on that way? And then I can replace it by an ERP system. And I think if you work on a decentralized validation part, it will help you really to have a really smart contracting system. And in the end, I think that smart contracting is the basic a part of autonomous data ecosystems if you talk about machine-to-machine communication. And even the graphs you show over here, I believe that it's right, the potential benefits you show us. But if you replace it by fake news, I think we had the same position. And so that's my issue. If we have the validation, then all the other questions are not an issue anymore, because we can guarantee it by decentralized validation. Then we are all talking about the same data, the validated data, and then you can start an accreditation. So how do you see that, Remco?
Yeah, so you're absolutely right. But there is no solution in any technology for the problem of having or not having correct data. If somebody entered either accidentally or maliciously incorrect data, right? So we're talking about data. It is not reality. It is a description of the reality, and it's just a fact that somebody can enter incorrect information. Then so there's no real way around this. So you need to solve this by setting rules, either in smart contracts. So these smart contracts can say, well, if somebody enters data, it always has to be checked by a second party, and otherwise I will not approve this, or yeah. So before somebody can buy it, it has to be approved by a second party. So you can enforce kind of accreditation rules through smart contracts. That would be a way, and you can use governance rules that optionally, well, that was a governance rule, right? So you can set governance rules that maybe checked by smart contracts. So that is what you need to do, but in the end, it will always be possible to enter incorrect data.
Yeah, I agree with that. That is a good issue to add. And I think it's more the definition of what's about rules. I'm looking to the technical part of rules, and the technical part of rules will say if the value is 1, then you can do that. But then you didn't do the validation of if the value 1 is really the true value. So I think it's more in the definition part that we have. But I agree that in the end we're talking about the same position.
Yeah. Let me quickly finalize the presentation, so we also still have sufficient time for my colleague from IBM, because right. So what you see here is a challenge. That because if Fokker would start to run this blockchain by themselves, they don't initially make any money. So one of the ways we saw around this is that blockchain can be used to enforce payment conditions, to enforce tighter payment conditions using these smart contracts. And there we saw a possible trade-off for covering right until the market has reached this 10 or 20% blockchain penetration, that we can still somehow make money out of it by using these smart contracts. So those are my main points. So I've shown you what blockchain, what you may want a traceability platform to do. I've shown you how blockchain can provide that functionality and what the potential benefits of it are. And I'm very curious, I've already had some critical questions, how you see maybe blockchain being used as traceability technology, or how you don't see blockchain used as traceability technology in your organization. I see a... Yeah, you're moderating. Go ahead.
Yeah, so there is a question from Wayne. We have a couple of questions. Maybe you can come in and address them right now.
Yeah, so Edwin?
Well, I can hear you very bad, Ben, but I have a question to you, Remco. How and where is the data stored actually in this blockchain solution which you presented? Is it centrally, or do you also work with distributed ledgers in the system or in the supply chain?
For our prototype, we actually use at this point a one blockchain installation, but that's just because it's a prototype. So in general, it is very easy to, you can basically, well, maybe I'm saying, but our technical person may have some opinion on that. So it should be very easy to just create a copy of the blockchain, install it, and it will communicate with the blockchain that you already have running, and it will make sure that all of these transactions are synchronized. So if you make a copy, you make a full copy immediately. And whether in the end you go for a distributed solution or a local solution is completely up to you or to the governance rules.
Okay, clear, Edwin? Okay. There is one more question from Sjoerd Groot, but I believe we can hold that question till at the end after we have seen the presentation of Jari from IBM.
So shall we move to Jari?
Yeah.
Okay. Then if everything goes well, you can see me and you can hear me.
Yes.
And then I will also share my screen. And then you should now be able to see my screen. Going presenter mode. There we go. Okay, so it should be visible to everyone. Feel free to interrupt me if you cannot see the slides. So my name is... yeah, it's okay, Ben?
Yes, it's good.
Okay, perfect. So my name is Jari van der Steen. I work as a senior consultant in blockchain with IBM. Today I've been asked to give a bit more of a presentation on the broader supply chain applications of blockchain. So everything you will see from here on is more of an addition to everything you have seen presented. So we really focused before this presentation on the aerospace part, spare parts, provenance, bit of which Remco showed the prototype that has been created for Fokker. And in this presentation, I would like to go into a bit more detail around different industries in where blockchain can be applied, but I'll keep it to the supply chain examples. So the biggest question will be, how can you change everyday life with blockchain? So maybe you have had this happen to you before. You've eaten something either in a restaurant or at home and you're getting sick. You know it's the food, but you probably don't know which food it actually was. And this is for a lot of supermarkets a big problem because people can get back in the store. They don't actually know what the problem is. Maybe they actually know which food, but they don't know exactly where they've gotten it or if it extends to other types of supermarkets all across the world. So one thing that did happen was in 2006, where a nationwide outbreak of E. coli linked to bagged spinach took 2 weeks to trace back to its source. So the source in the end was a local farm somewhere in the US, and it took 2 weeks to find out. So that means in those two weeks times, in different types of supermarket that's sold the same spinach, maybe in different types of bags, maybe from different distributors, they didn't know that it was that specific spinach that was making people sick. So one of the things we did with blockchain was create IBM Food Trust. We set it up initially with Walmart, and we had different other companies like Dole, Driscoll's, Unilever join as well in making sure we can put their products on a distributed ledger. So you can actually track and trace the food from the fork back to the farm where it initially came from. And that brings a lot of applications for consumers as well. So imagine now that with your phone, you can scan the label on the product, and you'll be able to actually get back to the same farm that actually the food came from. So let's imagine in this case, you get some tomatoes. You'll be able to trace back which distributors were in place, how much time it took to actually transfer the food from the farm to the supermarket with all distributors in between, and where it went, who the farmer is, maybe a bit about the farmer itself that actually grew tomatoes. And that will be possible not in 7 days, but in 2.2 seconds. So we created that using the IBM blockchain platform, and quite recently, actually just last week, we open sourced the operations console of the IBM blockchain platform as well into the Hyperledger Fabric code. So IBM was the initial donator of, with some other companies like Intel, of Hyperledger Fabric, which is a blockchain implementation that has also been used in the prototype that we've seen for Fokker. So it is a distributed ledger technology. It's not open and permissionless in the sense of Bitcoin. It's still open, but it's permissioned. So that means only authorized parties can actually access the network, and not just everyone. Also maybe playing in a bit to the validation. You'll be able to spin up your own thing, and you'll be able to create a distributed ledger. So you can spin up your own node, which you can consider as your own database, and others can spin up their own node, which is their own database. And then the data will automatically be kept in sync via the blockchain mechanism that's in place there. This operations console provides easy ways to actually manage those type of things. So maybe a bit back to Food Trust. So what does it actually provide you as the end user? It provides you end-to-end traceability from farm to fork and full transparency of everything in between. What conditions were products shipped under, which companies were in the loop, and did you make use of? So that means that, for example, in the Netherlands, we had problems with meat at some point. You can easily see, okay, from this company, so let's say you're a supermarket, from this company, I received my meat. And there have been issues in different supermarkets. Let's get them out of the shelves as quickly as possible before we know what's going on. So our consumers will not be affected by potential food contamination. But next to that, you can also think about optimizing your own supply chain. So if you start adding things on this traceability, like what's the temperature in which products have been shipped to me? Chicken, for example, is not allowed to go above 4 degrees Celsius. Let's say at some point during the trip, it was higher. Now you can trigger a smart contract to say this was actually crossed, and now I have to sell the chicken, or I cannot buy the chicken anymore quicker. Or so I can actually get discounts based on that and do all the ways of settlement. We can even go further than this. We can also look into new solutions built on top of this Food Trust Foundation. And we can work with coffee. So again, coffee we can track from farm to the moment of actual consumption, maybe in a bar, restaurant, or at your home. Let's now say that you'll also be able to scan that coffee, and you actually can trace it back to the farm. But this time you can add features on top of that. And that's what has been done with Farmer Connect, for example. So with Farmer Connect, you can scan your coffee, and you can actually go back, okay, where did my coffee come from? You can find the individual farm, and you can read more about the farm. And you can also, what's called thank your farmer, donate to the farmers themselves. Most of the farmers are from low-income countries, and especially small-scale farmers can be further incentivized for the coffee they produce. Next to this, it can also be used for sustainable projects. So as a result, you can read more about different projects, maybe the farmer itself is involved with, or the product that you're buying, and you can get some incentives around that. For example, donating to a charity or project around those things. So let's take a step back and look outside of the retail and food industry and consider container shipments. So another blockchain-based solution that we have thought about was TradeLens. And I saw someone actually ask a question already around the Maersk case, and that is very much this case. So TradeLens was actually born as a partnership between IBM and Maersk in a way. And initially, there was the case that Maersk was, in the view of other companies, trying to dominate the entire global marketplace around container shipping, because they, as a platform, if you contributed, the data is owned by them. Well, that changed. So the data is not just owned by everyone that makes use of the platform. It's not like you share your container shipment data on a platform, that this will be owned by the platform itself. You, as a contributor to the blockchain, by sharing the data, providing insight to others, and others providing insight back to you, you keep ownership of that data, and you decide which parties to actually share that data with. So Maersk in no case owns the data in that way, and TradeLens in and on itself is an independent company to host the platform with outside investment. So if we look at the ecosystem picture in the top right of this slide, you see a very similar picture to what Wouter has shown you in his presentation. A disparate ecosystem of many connections between different companies, some companies being linked to other companies, maybe through the trusted third party. And there's a better way to do it. You can get this single rail, as you could see it, which is the blockchain, to actually work together on a single view of the data. So especially with TradeLens, we are focused on sharing container-based shipment data on a blockchain, so we can optimize the time in which, for example, customs can work with these containers. So instead of having this paper-based document or PDF sent by mail or via some other means, you'll be able to get to the data using the platform. You'll be able to view, okay, we have this bill of lading from this company that's coming in. This is a very regular transaction, and therefore customs might not need to do additional checks. So let's imagine you're a very large company, maybe Nike even, and you're shipping this a container full of shoes to the Netherlands. So people are waiting for those shoes to actually arrive, and now customs is doing a check. That can actually increase the time for you to get your product to consumers by over a week. So this is definitely not something you would like as a company, especially if you feel in a way you are doing these trusted shipments and you're making sure that nothing wrong is going inside the container. So in this way, you can actually share a lot of data upfront, and this can help customs as well in doing better checks on which containers they actually need to work with. We also have done work around ethical and sustainable sourcing with the Responsible Sourcing blockchain network. So here, IBM and RCS Global have teamed up to create a blockchain platform where you'll be able to actually track minerals from the site in which they are mined to the OEM. So let's say you are a car manufacturer and you want to put a battery in your car. So you're an EV in the EV world, you'll actually get the battery. Sorry for that. Now, a lot of cobalt is being mined in now I have to say it correctly. I forgot the word for that, but it doesn't matter. A lot of cobalt is being mined in areas where there's a lot of problems with ethical mining, where child labor and those type of things are involved. And for a car manufacturer, it's very difficult to find out if cobalt that they actually put in a car battery comes from a mine like that. So if there is a incident, going on in some mine and it has high news coverage. You as a automotive manufacturer might think like, oh, maybe I get my minerals or my materials that I use in my batteries from this site, but I will never know. Because as you've seen from the presentation from both Wouter and Remco, in your supply chain, you mostly have your downstream and your upstream partner in your supply chain, which you trust, but you might not even know the upstream parties that they work with. So this network actually aims to map that entire network. So at the end, you as an OEM can actually see, okay, you have your mine, you have a smelter, you have a refiner, and you have manufacturers even before you manufacture the battery yourself or have the battery manufactured and procure it. You'll be able to see how many of that is actually tracked on the platform and you can use in your car batteries. So we call that verified and traceable cobalt. We have talked about a few supply chain cases now, and they all have a very similar flow to them in terms of the supply chain flow. You have your upstream, downstream, you have increased visibility. You want people to provide data to the blockchain, work together with you on a blockchain network so that you, as the most downstream party, can do additional traces and know where you actually source your goods. And as an upstream partner, you'll create more visibility with these downstream parties, and you can enhance the trust they place in you by being part of a platform where full transparency is given in the fact that companies procure from you and that you provide good quality goods. So based on the foundation that you've seen with IBM Put Trust and also with the Farmer Connect solution, IBM has worked to create a solution called IBM Blockchain Transparent Supply. So this is an accelerator to build your own blockchain supply chain. So to go over a few things of the things that are actually contained in this solution, you still have your trace module, you still have documents that can be digitized and uploaded and shared with others. Again, you share the data with the people that want to see the data that you share and that you explicitly share with you. You remain the owner, you can share the information, you can also revoke access to that data shared. And you can also define which parties are not allowed to see certain information. So since it's not a permissionless blockchain, not everything is shared into the public, and documents are also just shared in a confidential manner on the blockchain. Just something to have clear. So in this solution, we actually provide you with all the tools to actually be able to work with documents, traceability, onboard different parties to your solution. I keep saying it as if it's your solution. There are multiple ways to approach it. You can say a company starts their own blockchain and tries to get all the people on board. You can also already start working together with different parties in a consortium to already overcome that first hurdle. So the investment hurdle that was also already mentioned in the diagram that Remco showed already required a certain part of the market to be involved. And there we also have the early adopter fee in a way. So it costs you some money in the beginning, but it will pay off in the end. You can kind of kickstart that by already forming partnerships together and already starting with an end-to-end flow to cover multiple businesses. I think I'm already pretty much on time, so I'm going to finish this one up. With IBM, we're working in different industries with different types of solutions. I covered a lot about provenance, food safety, and retail today, but we're also active in the trade finance area, identity area, energy area, and even healthcare and insurance. Make sure you reach out if you have any further questions. And I'm going to end it with that.
Okay, Jan, thank you very much. I think there is a specific question by Loes Willekens. how do you provide an incentive to upstream and downstream parties to adopt the blockchain technology?
Yeah, that's a very good question. Yeah, so that's indeed a almost a field of science in itself called incentive design. So how do you actually incentivize them? So one of the examples, for example, with the mining example that I gave, is for you as the further downstream parties, let's say the battery manufacturer, you want that insight. So what do you actually give to those individual miners to join? Because in a way, you're giving them more administrative overhead, but you're also giving a way to them to be more trustworthy and be able to connect with other companies, so they can expand their operations and work with different types of partners. So that's just one way. If you look from the farmer perspective that we gave as well, you can also see that you can give them more visibility, be able to provide donations, but also if they are part of that trusted ecosystem, you can also have some influence on price, because in a way you're giving additional service and adding to the products that you deliver. There are also ways called, you have tokenization as a way where parties that actually provide services on a blockchain can be reimbursed for their efforts as well with a platform native token, where they could also spend that again to get other services on the platform as well. So you as a service provider can actually get those tokens, which you then can exchange for other services on the network as well. I hope that answers your question.
Yeah, thank you.
Okay, there was another question, Jari, from Edwin Wenning. Jari, is this not a data pipeline because validation is missing?
Which specific solution were you talking about, Edwin?
Can you hear me?
Yes.
Okay, especially the last part of your presentation, when you were talking about entering data, because sorry, I see a lot of the resemblance with the core project where we were actively in when I was still working with Royal Flora Holland. We were actually building a kind of data pipeline where everybody could build, let's say, put their information to the system and connect via the data pipeline the information to all the participants in that trusted system. So, but that was not a blockchain; it was a data pipeline. So, because validation was not of the essence. So, for me, blockchain is always where you have a transaction which is validated. And if you just upload your information, let's say phyto certificate or something like that, then it's not validated by anyone, only that it's uploaded and you can reuse it.
Yeah, so, okay, so there are different ways to address this, which are pretty much dependent on the actual solution. So the official answer is it depends, but you can think of different ways, right? So Remco and you already talked about this. So you can have smart contracts validating the information that you actually put in. Let's take it at a more high level. You can take the business perspective. Is the data correct from the perspective of your private business? And for that, you have an ERP system, right? So you have your validation rules, you have that in the ERP system for different operations that you have. Then you can also look at it from the ecosystem perspective. So what's actually the information that maybe an auditor wants to see, that information that you share with others? There you can use smart contracts to validate. You can also bring other parties on board that perform validation services on the network itself. And that's also, in a sense, a validator of that part of the network. So that could also be a way.
Okay, but then you need a neutral body to have that.
Yes, in a way. So if you look at the food example, you have certain certifications that distributors need to have, and the actual certification you can add that to the profile of such a distributor on the blockchain as well. So you know you're working with certified parties.
Okay, clear. Thank you.
Okay. I believe there are still some questions open, but it's right now it's time to end this webinar. Certainly, with a project like this on the, let's say, on the innovation starts, people start to think about these things, and there are questions to be answered. We will share the information about this webinar with all the people on this call, and we will put some email addresses of the speakers so that you are able to ask them some questions or get in contact with them for some further information if you want. Sorry to disconnect here. All these questions still open, but I believe the main questions are being answered throughout this webinar. I would like to thank all the speakers, Wouter, Remco, and Jari, giving their perspective on this project. I believe that with this project we have made a step forward in enabling the blockchain technology in a specific area, and Jari has given us some views about other developments that are ongoing in the supply chain land or in the service chains. Thank you for being here as an audience, and we will hope you will enjoy. By the way, SLS is organizing more of those events about this year, about technology enabling, like artificial intelligence, and about digital twinning. And we have our Service Leadership Summit in November, and that will be a physical summit, providing the pandemic is not overtaking that. Thank you again for joining, and we are back with other subjects. Bye.
Thank you, Ben.